This program worked 5 minutes ago. Now on a different computer, it's completely broken, and nobody touched a single line of it. A program that ran perfectly a minute ago just crashed, and nobody touched the code. Here's the strange part. The code didn't change. The computer underneath it did. So, the bug wasn't really in the program at all. It was in everything sitting around it. Most explanations of this jump straight into the fix. I think that's backwards. So let's start with the disaster, because the fix only makes sense once you've felt the pain. Picture a recipe from your grandmother. It doesn't just need instructions. It needs her oven, her ingredients, her kitchen. Your friend's kitchen has a different oven, cheaper flour, and thinner air because they live somewhere higher up. So the exact same recipe can bake beautifully for you and fail completely for them. And the recipe was never wrong. For now, think of Docker as a box that ships the whole kitchen, along with the recipe, oven, ingredients, everything. That's a simplification, and I'll show you exactly where it breaks later, because it changes what you actually install. Before I explain it, guess, what's actually different between your computer and your friends? It's the invisible stuff. Which programs are already installed, which versions, which settings are silently assumed. But your program doesn't know any of that. It just assumes the world looks like yours. So, programmers gave that invisible stuff a name, the environment. Everything a program needs that isn't the code itself, but listing every missing piece by hand on every computer, is exactly the kind of tedious work that breaks things. So, the real question becomes, how do you package the environment itself, not just the code sitting inside it? Docker's answer: package the whole environment, operating system pieces, libraries, and settings, into one sealed unit. They called that sealed unit a container. Imagine shipping the recipe and the exact stove, the exact pans, together. Not a shipping container, well, actually, almost exactly that, borrowed on purpose. Decades ago, shipping got chaotic too. Every port loaded cargo differently, by hand, painfully slow back then. Then, someone standardized the box itself. Any cargo, any ship, any crane, identical fit everywhere. Docker containers standardize software the same way. Any app, any machine, identical result every time. But it isn't a full computer crammed inside a box. That's a completely different idea. So what's actually different between a container and a full virtual machine? One of them hauls around an entire second operating system. The other one doesn't. That one difference changes everything about how heavy, how fast, and how portable it is. A virtual machine packs a whole fake computer inside itself, its own kernel, its own boot process. A container skips that entirely. It borrows the host machine's kernel instead of dragging its own. That's why it starts in seconds, not minutes, and weighs megabytes, not gigabytes. Same isolation, dramatically less baggage. But here's a fair objection. What if two apps need two totally different versions? Say one project needs Python 3.8, another needs Python 3.11. Both run fine, side by side. Each container carries its own version, sealed off. They never see or conflict with each other. But where does that sealed box actually come from in the first place? You build something called an image, a frozen snapshot of that whole environment, saved once. Run that image, and it wakes up as a live container, the recipe becoming an actual dish. Not the sealed box itself, a blueprint for stamping out that exact box, anywhere, anytime. Ship that image to a coworker, a server, or a laptop on another continent entirely. It behaves identically every time because the full environment traveled with it, not just the code. The kitchen doesn't matter anymore. The recipe now carries its own kitchen wherever it goes. That 5-minute mystery from the very start, solved. No more "it works on my machine" arguments in the team chat at midnight. Not by fixing a single line of code, by packaging the entire world around it. So, how does someone actually build one of these things themselves? Turns out it's one small text file, a short list of plain instructions, nothing exotic. 5 lines, and the entire environment gets written down, once, permanently, for good. No more tribal knowledge, no more setup wikis nobody trusts, no more guessing. That's next. The 5 lines that end the "it works on my machine" excuse for good. Here it is, 5 lines, and none of them look like the code you've written before. Line 1. From Node 18 means start from a computer that already has Node version 18 installed. Not your version. Not whatever got installed on your laptop 3 years ago. Line 2. Copy.app copies every file in your project into that frozen computer, like packing a suitcase. Line 3 just says, work from inside that folder now. Line 4 is the important one. Run npm install. It installs every dependency your app needs, inside the image, not on your machine. Imagine your coworker has npm version 9, and you have version 8. That mismatch alone can break everything. Line 5, CMD, the instruction that runs the moment this computer wakes up. That's it, 5 lines, a whole computer described like a recipe card. But a recipe is not a meal. How does this turn into something that actually runs? You don't run a Docker file. You build it first, and that word matters. Docker reads those 5 lines and assembles them into a single frozen package, an image. Think of the image as a sealed box. The base computer, your files, everything installed, ready to go. But a sealed box just sits there. It isn't running anything yet. So, you run it. Docker run. And that's when the box wakes up. That running instance has a name too, a container. One image, run twice, gives you 2 separate containers, like baking 2 cakes from one recipe. Each one thinks it has its own computer, its own files, its own node, its own everything. Crash one, and the other doesn't even notice. Delete one entirely, and the image itself doesn't even blink. It's still sitting there, untouched. That's the whole trick. Not magic, just a box built once and copied perfectly every time. This is why they called it Docker in the first place. A real shipping container doesn't care what's inside. Crane lifts it exactly the same way every time. Shoes, engines, furniture. From the outside, every container looks identical. Your app is the cargo. The image is the container. The server is the crane. The server never has to understand your code. It just lifts the box. You might expect a whole separate operating system underneath, but it doesn't. And that's the clever part. That's why those 5 lines run identically everywhere. Your laptop, a coworker's, a server across the planet. No more, it worked on my machine. Now, it just works. That's the entire problem Docker was built to fix. Not containers for shipping, containers for code, doing exactly the same job. So, next time someone says just Docker it, you'll know exactly what they mean. Docker isn't the box. Docker is the engine that builds the box every single time. That engine runs quietly in the background on your laptop, a server, any machine that has it installed. It doesn't care if the underlying computer runs Windows, Mac, or Linux underneath. It's called the Docker daemon. Think of the daemon as the kitchen manager, always listening for your next order. No engine running? You'll see this error. Cannot connect to the Docker daemon. Maybe you closed Docker Desktop by accident, or it never started when your computer booted. That single click, Start Docker, fixes almost every "it's broken" mystery beginners hit. So, before any of this works, one thing has to be true. Docker itself must be running. Then, with one command, the engine reads your blueprint and assembles the exact same kitchen instantly. Same oven. Every time. Remember that program that broke the moment it left your laptop? Package it inside Docker, and that exact failure disappears. Same engine, same box, everywhere it runs. Different Python version, missing library, wrong OS setting, any of it can break things. Not because the code got smarter, because the kitchen stopped changing. Even if you've never opened a terminal, this happens with photo editors, games, spreadsheets, anything. Has an app or a game ever worked perfectly on your phone or laptop? Then completely broken on someone else's. What happened? Maybe a game ran fine on your PC, then lagged or crashed entirely on your friends. If that's ever happened to you, even with something that isn't code, tell me the story in the comments. I read every one. That's the whole idea behind Docker, boiled down to one sentence. The box was never really about the code. It was about giving every kitchen the exact same oven, so your work never depends on luck again.